Yes, if a single outlet for a washing machine is located within 6 feet of a sink, it is required to be ground fault circuit interrupter, or GFCI protected. The National Electrical Code, or NEC, mandates GFCI protection in specific locations to enhance electrical safety and minimize the risk of electrical shock. In the context of laundry areas, this requirement particularly applies to receptacles serving laundry equipment, such as washing machines, especially when these receptacles are situated in close proximity to water sources like sinks. The reasoning behind this regulation lies in the increased potential for water to come into contact with electrical components or appliances, thereby creating a hazardous environment. Water is a conductor of electricity, and when it bridges the gap between an electrical source and a person, it can result in a severe or even fatal electric shock. GFCI devices are designed to detect even the smallest imbalances in electrical current flowing through a circuit. They work by monitoring the difference in current between the hot and neutral conductors. In a properly functioning circuit, the current flowing into the circuit through the hot conductor should be equal to the current flowing back out through the neutral conductor. However, if a ground fault occurs, such as when current leaks to ground through a person or a grounded object, the GFCI will detect this imbalance. When the GFCI detects a current imbalance exceeding a predetermined threshold, typically around 5 mA, it will quickly trip the circuit, interrupting the flow of electricity and preventing a potentially dangerous electrical shock. This rapid response time is crucial in minimizing the duration and severity of the shock. The NEC specifies various locations where GFCI protection is mandatory, including bathrooms, kitchens, garages, and outdoor areas, in addition to laundry areas. These locations are identified as having a higher risk of electrical shock due to the presence of water or other conductive materials. In laundry areas, the presence of water from washing machines, sinks, and other plumbing fixtures increases the likelihood of electrical hazards. The 6-foot proximity rule is a guideline used to determine the extent of GFCI protection required around sinks and other water sources. Receptacles located within this zone are considered to be at a higher risk of exposure to water and therefore necessitate GFCI protection. This requirement applies not only to receptacles directly serving washing machines but also to any other receptacles located within the 6-foot zone. When installing or modifying electrical wiring in a laundry area, it is essential to adhere to the NEC requirements and ensure that all applicable receptacles are properly GFCI protected. This can be accomplished by installing GFCI receptacles directly at the point of use or by providing GFCI protection upstream at the circuit breaker panel. GFCI receptacles are designed to replace standard receptacles and provide built-in GFCI protection. They typically have test and reset buttons on the face of the receptacle, allowing users to periodically test the GFCI functionality and reset it if it trips. GFCI circuit breakers, on the other hand, are installed in the circuit breaker panel and provide GFCI protection for the entire circuit. They also have test buttons for periodic testing. To determine whether a receptacle is GFCI protected, it can be tested using a GFCI tester. This device plugs into the receptacle and simulates a ground fault condition, causing the GFCI to trip if it is functioning correctly. If the GFCI does not trip, it indicates that the receptacle is not properly protected and requires attention. It is important to note that GFCI protection is not a substitute for proper grounding. Grounding provides an additional safety measure by providing a lower resistance path for fault current to flow back to the source, helping to trip the circuit breaker and clear the fault. In addition to GFCI protection, other safety measures should be taken in laundry areas to minimize the risk of electrical shock. These include keeping electrical cords and appliances away from water sources, avoiding the use of extension cords, and ensuring that all electrical equipment is properly grounded. Regular inspection of electrical cords and appliances is also recommended to identify any signs of damage or wear. Damaged cords or appliances should be repaired or replaced promptly to prevent electrical hazards. Furthermore, it is crucial to use appropriate electrical outlets and wiring for the intended application. Overloading circuits can lead to overheating and potentially cause fires. If additional outlets or circuits are needed, it is best to consult with a qualified electrician to ensure that the electrical system is adequate and safe. Proper installation and maintenance of electrical systems in laundry areas are essential for protecting occupants from electrical shock and other electrical hazards. By adhering to the NEC requirements and implementing appropriate safety measures, the risk of electrical accidents can be significantly reduced. In summary, the requirement for GFCI protection for receptacles serving washing machines within 6 feet of a sink is a critical safety measure designed to prevent electrical shock. By understanding the principles of GFCI protection and following the NEC guidelines, homeowners and electricians can ensure that laundry areas are safe and free from electrical hazards. It is always recommended to consult with a qualified electrician for any electrical work to ensure that it is performed correctly and in compliance with all applicable codes and regulations. If you are unsure about the GFCI requirements in the laundry area, consult with a qualified electrician or local electrical inspector for clarification. They can provide guidance and ensure that the electrical system meets the necessary safety standards. Remember that electrical safety is paramount, and taking precautions to prevent electrical shock can save lives. Firstly, GFCI protection is essential in laundry areas due to the presence of water and the potential for electrical hazards. Secondly, the 6-foot proximity rule ensures that receptacles near sinks and other water sources are adequately protected. Thirdly, proper installation and maintenance of electrical systems are crucial for electrical safety. Fourthly, consulting with a qualified electrician is recommended for any electrical work. Fifthly, always prioritize electrical safety and take precautions to prevent electrical shock. The next, specifically Article 210.8, details the requirements for GFCI protection. These requirements are in place to minimize the risk of electrical shock in areas where water is likely to be present. The 2023 version of the NEC states that all 125-volt through 250-volt receptacles installed in laundry areas must have GFCI protection. This requirement applies regardless of the receptacle's proximity to a sink or other water source. This comprehensive approach ensures a higher level of safety in laundry areas. The distance of 6 feet is a common benchmark used in electrical codes to define areas where increased protection is needed due to the presence of water. However, the specific requirements can vary depending on the addition of the NEC and local amendments. Always consult the latest edition of the NEC and local codes to ensure compliance. The role of a GFCI is to detect imbalances in the electrical current. It constantly monitors the current flowing through the hot and neutral wires of a circuit. In a normal circuit, these currents should be equal. If a ground fault occurs, meaning that some of the current is leaking to ground through an unintended path, the GFCI will detect this imbalance. When the imbalance exceeds a certain threshold, typically around 5 mA, the GFCI will trip, quickly cutting off the power to the circuit. This rapid response can prevent a dangerous electrical shock. There are two main types of GFCI devices: GFCI receptacles and GFCI circuit breakers. GFCI receptacles are installed in place of standard receptacles and provide GFCI protection at the point of use. They typically have test and reset buttons on the front, allowing you to periodically test the device and reset it if it trips. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. They also have a test button for periodic testing. In a laundry room scenario, either a GFCI receptacle or a GFCI circuit breaker can be used to provide the required protection. The choice depends on factors such as the existing wiring and the desired level of protection. Using a GFCI receptacle provides protection only at that specific outlet, while a GFCI circuit breaker protects all outlets on that circuit. Testing a GFCI is a simple process. You can use the test button on the GFCI device. Pressing the test button should cause the GFCI to trip, cutting off the power to the circuit. You can then reset the GFCI by pressing the reset button. It is recommended to test GFCI devices monthly to ensure that they are functioning properly. There are also GFCI testers available that plug into the receptacle and simulate a ground fault, allowing you to verify that the GFCI is tripping correctly. Grounding is a separate but equally important safety measure. Grounding provides a low-resistance path for fault current to flow back to the source, helping to trip the circuit breaker and clear the fault. This helps to protect against electrical shock and equipment damage. In a properly grounded electrical system, the metal enclosures of appliances and equipment are connected to the grounding system. If a fault occurs, the fault current will flow through the grounding system back to the source, tripping the circuit breaker and cutting off the power. GFCI protection and grounding work together to provide comprehensive electrical safety. GFCI protection protects against ground faults that may not be detected by the grounding system, while grounding provides a path for fault current to flow back to the source, helping to clear the fault quickly. Both measures are essential for minimizing the risk of electrical shock and equipment damage. In addition to GFCI protection and grounding, there are other safety precautions that should be taken in laundry areas. Keep electrical cords and appliances away from water sources. Never use electrical appliances with wet hands. Avoid overloading electrical circuits. Inspect electrical cords and appliances regularly for damage. If you notice any damage, such as frayed cords or cracked housings, repair or replace the item immediately. Use appropriate electrical outlets and wiring for the intended application. If you need to add outlets or circuits, consult with a qualified electrician to ensure that the electrical system is adequate and safe. Finally, never attempt to perform electrical work unless you are qualified and knowledgeable. Electrical work can be dangerous, and it is always best to leave it to the professionals. In summary, the NEC requires GFCI protection for receptacles in laundry areas to minimize the risk of electrical shock. The 6-foot rule is a guideline used to define areas where increased protection is needed due to the presence of water. GFCI devices detect imbalances in the electrical current and quickly cut off the power to the circuit in the event of a ground fault. Both GFCI protection and grounding are essential for comprehensive electrical safety. By following these guidelines and taking other safety precautions, you can help to protect yourself and your family from electrical hazards in the laundry area.